the coordinate planes and axes associated with the trajectory, the article 8.2 of the book Mechanical Systems Calculations of the Marine Facilities. We consider the natural way of the assigning of the motion of the point in the mechanics and kinematics, etc. So let's consider the trajectory shown on the figure H21 is. So we have the point M. Point M moves from the definite one point to the location of the M1 by the trajectory indicated on the figure. Tau is the direction of the axis, which is a tangent to the trajectory of the motion of the point M. In the point M1, we have tau1, the same axis, tangential axis, which we take this directory of tau1 and we'll move this to the point M. We will have tau1 here. We have two vectors. Having two vectors in the point M, we can define what is the plane determined by these two vectors. This is a definite plane, like we can say that this is the osculating plane, the word osculating. So if we will tend to the very small distance of the point motion delta s, we tend this as like the increment to zero, we will find the limiting position of the osculating plane. This limiting position of the osculating plane we can indicate on the figure H.2.1p. This is osculating plane P1. In this plane we have the two axes. We first is the tangential axis, tangential of the direction of the motion of the point M and of the tangential acceleration of the point M. And besides, we can find the perpendicular plane P2. We can say normal plane perpendicular to the direction of the motion in the definite one moment of the point M. This plane P2 will be the normal plane, and the line of the oscillation, line of the intersection of the osculating plane P1 and the normal plane P2, we will have the main normal axis. So the first axis is the tangential axis, and another one, main normal axis, as the result of the intersection of the osculating plane like the limiting location of the plane defined by two vectors of the point M when it moves by the trajectory. If we will tend the increment of the motion of this point M to zero, we will have this plane osculating, and we will next have perpendicular to the tangential axis of the direction of the motion of the point M, and the perpendicular plane is the normal plane, and the line of the intersection the main normal. And having these two axes as the tangential axis and the main normal axis, we can find as well the perpendicular binormal direction, and the so-called straightening plane. This one, which is the plane in which we have the tangential direction of the axis, and at the same time, this is plane perpendicular to the normal plane, or perpendicular to the osculating plane. This is so-called straightening plane. Make it straight. So, and in the intersection of the normal plane and straightening plane, we will have the next axis, axis B. Axis B is the binormal axis. This is a right-handed system of coordinate. If this system of coordinate, the natural system of coordinate moving with the point M, if the system of coordinate is right-handed, then if we rotate the axis tau to direction of axis N, the right screw will move along the axis B, binaural axis. If we rotate tangential axis to main normal axis, the right screw will move along the binormal axis. This is the main planes of the trihedron for the natural coordinate system, and the main axis of the natural coordinate system, where we assign the motion in the moving with the point coordinate system by the natural way. Questions and comments. Coordinate plane in contact with the trajectory of the motion of a point, the limiting position of the plane on which the tangents to the trajectory of the point of movement of the different is in its different position, which tend to each other along the trajectory. Yeah, we can move the vectors, tangential vectors coincides, orths, maybe unit vectors, or orths of the motion, or directions of the motion of the point along the trajectory. So the limiting location. These two orths are inclined exactly to each other, and they defined the plane. So two vectors can define the plane. Two vectors, if not, if they are intersects and they are inclined to each other, they can define the plane, in which these two vectors are. So if we tend uh, the way of the length of the arch of the motion of the point M along the trajectory, having the directions of the tangential axis and the points of the motion of the point M. So the limiting position of the plane, which possesses, which covers two directions. Limit position of plane is the so-called osculating plane for the point of the motion trajectory. And yeah, this is when we tend the way to zero of the motion by the trajectory, and considering the two locations of the point in the osculating plane. To the flat trajectory of motion of material points completely located in the conducting plane. Yeah, flat trajectory, yes, is in the osculating plane completely. 8.2.3 is the normal coordinate plane passing through the point perpendicular to the tangent line to the trajectory of the point. Yes, it is. To find the normal coordinate plane to the trajectory of the motion, we have to have the tangential axis in the direction of the motion of the point, and the perpendicular plane is the main plane, and the line of the intersection of the is normal plane, and the line of the intersection of normal plane and the osculating plane gave us the axis of the normal of main normal axis directed to the way of to the convexity of the trajectory of the motion. 8 to 4, the main normal of the trajectory of a point motion is a line of the intersection of normal tangent coordinate planes. Yes, the main normal and the direction of the main normal coincides with the direction of the convexity of the trajectory of the motion at the point M. 8 to 5, rectifying coordinate plane passing through the moving point perpendicular to the main normal. We have rectifying, or we can say that strengthening coordinate plane passing through the moving point perpendicular to the main normal, and the intersection of the rectifying or strengthening coordinate plane with the main normal plane gave us the binormal axis in the right-handed coordinate system corresponsive to the rule of the right screw. If you rotate the tangential axis in the moving coordinate system associated with the natural way of the assignment of the motion of the point M, and the coordinate system moving together with the point M. When we rotate in this coordinate system the tangential axis to the axis of the main normal, the right direct associated with the tangential axis, right screw will move to the direction of the binormal axis of the right-handed coordinate system, and the line is the intersection of the normal plane perpendicular to the tangential axis and the point considered M, and with the intersection with the so-called rectifying coordinate plane or straightening coordinate plane. The axis of moving coordinate system associated with a point when the motion of the point is naturally specified which are intersectional coordinate planes, scalarity, normal, and rectifying. Rectifying or stretching coordinate plane. The 827, the direction of unit vectors of coordinate axis with a natural specification of the point's motion, the unit tangent of the trajectory of the axis directed towards the reference of coordinate of the trajectory, the unit of the main normal, and in the direction of the concavity of the motion trajectory of the point, and the unit of the mean normal in the direction of the vector product of the unit vectors of the tangent and normal and the main normal. So yes, we discussed that the direction of the normal axis relatively the tangential axis. The main normal axis is direction corresponds to the concavity of the motion trajectory, concavity to the direction of the center of the concavity of the motion trajectory. The binormal is a positive direction, and the unit of binormal in the direction of the vector product mean that for the vector product we use the right of the right crew. If we rotate one with the first vector to the direction of another one, so then the right crew will be directed onto the product of two vectors. The product's binormal axis could be considered as a product of vectors of tangential ords and the vector of the main normal ord. Thank you.